into our eyes, and then we will be able to see the objects. Light travels in straight lines, and light traveling in one direction is called light ray. If all the light rays are parallel to each other, we call them parallel light rays. If the light rays are starting from a point, then we call them diverging light rays. If the light rays are going to meet at a point, we call them converging light rays. Now let us look at the laws of reflection of light. If a light ray is incident on a surface, the point at which the light ray is incident, we call it point of incidence. The incident ray will get reflected. We call this reflected light ray. An imaginary line perpendicular to the surface at point of incidence is called normal. The first law says the incident ray, normal, reflected ray, all the three lie in the same plane. If you rotate this table, we can see that the incident ray, normal and reflected ray, they are in same plane. The second law of reflection. The second law of reflection says that the angle of incidence is equal to angle of reflection. I should be equal to R. Let's revise the characteristics of images formed by plane mirrors. If we observe the images formed by plane mirrors, we can see that the image will form at the same distance as the object from the mirror. Also, the size of the image is equal to the size of the object. The third characteristic is the images will be erect. That is, the top will remain top, the bottom will remain bottom. The fourth characteristic is the images are laterally inverted. Left appears to be right and right appears to be left. Next is the image formed by a plane mirror is virtual. Virtual means the image cannot be captured on a screen. Now let's discuss spherical mirrors. We see in our day-to-day life spherical mirrors at various places. This is a mirror kept on the roadside. This is a convex mirror used in a vehicle. This is a concave mirror which is used in a telescope. This is extremely large telescope present in Atacama Desert in Chile. You can see how big the mirror is. Look at the trucks and cars which are near the entrance, which are so tiny when compared to the mirror here. This telescope is used to observe celestial objects in the space. In our day-to-day life, we observe spoons. Spoons also act as spherical mirrors. They also form images when they are new, and as you are using the spoons, they lose the luster and they become dull. So you can observe that the spoons are forming images. On the right side, the image is erect. On the left side, the image is inverted. Spherical mirrors are part of a sphere. So the mirror which is made from a sphere is a spherical mirror. If you paint on the outer surface, it is called the concave mirror. The inner surface will act as a mirror. It's a concave mirror. If you paint the inside, then the external surface will act as a mirror. This is convex mirror. So let's discuss concave mirror. The middle of the mirror is called pole of the mirror. The center of the sphere of which mirror is a part is called center of curvature. The line joining center of curvature and pole of mirror is called principal axis. The distance between the pole of the mirror and the center of curvature is called radius of curvature. The length of the mirror is called aperture. In this chapter, we assume that aperture is much smaller than the radius of curvature. Now imagine a light ray which is parallel to principal axis is incident on the concave mirror. After reflection, it passes through a point on the principal axis. If we consider another light ray, this also gets reflected in such a way that it passes through the same point on the principal axis. So all the light rays which are parallel to principal axis, when they are incident on the mirror, pass through a point on the principal axis which is called focus. Principal focus. And the distance between principal focus and pole is called focal length. Using the assumption that aperture is much smaller than the radius of curvature, we can prove that radius of curvature is twice the focal length, that is r is equal to 2f. Let us solve a numerical. Radius of curvature of a concave mirror is 20 centimeters. Find the focal length. We know r is equal to 2f, so substituting the value of radius of curvature 20 is equal to 2f. F is equal to 20 by 2, so it's 10 centimeters. Let's solve another numerical. Radius of curvature of mirror is 50 centimeters. So find the focal length. So r is equal to 2f. So substituting the value, 50 is equal to 2f. F is equal to 50 by 2, which is 25 centimeters. Let's solve another numerical. Focal length of concave mirror is 22 centimeters. Find the radius of curvature. R is equal to 2f. So r is equal to 2 times 22, which is 44 centimeters. Now let us revise the rules to draw ray diagrams in case of a concave mirror. A light ray passing parallel to principal axis incident on the concave mirror passes through focus after the reflection. When light ray passes through focus, after reflection, it passes parallel to principal axis. The third rule, when light ray is passing through center of curvature, after reflection, it retraces the path. That is, it gets reflected in the same direction. The fourth rule, when light ray is incident on the pole, it gets reflected in such a way that the angle between the principal axis and the incident ray will be equal to the angle between reflected ray and the principal axis. Here principal axis is the normal at pole, and hence the angle of incidence is equal to angle of reflection. So let us revise all the four cases. Light ray which is passing parallel to principal axis passes through principal focus after reflection. Light ray which passes through focus after reflection comes out parallel to the principal axis. Light ray which is passing through center of curvature gets reflected in the same direction. And the last, when the light ray is incident at the pole, it gets reflected in such a way that the angle with principal axis is same. Now, using these rules, let us draw the image of an object which is present here, that is beyond center of curvature. To find the image formed, we have to select any two of the rules, four rules. Repeat, to find the image formed by the concave mirror, we have to select any of the two rules from the four. Repeat, to find the image formed by the concave mirror, we have to select any two light rays from the tip of the object. So I will select a light ray which is parallel to principal axis, which is coming from the tip of the object, and after reflection it has to pass through principal focus. The second light ray which I am going to choose is the light ray which passes through focus. After reflection it has to come out parallel to the principal axis. Now, where the light rays meet, there the image is formed. If we see the image is inverted, it is smaller in size and it's a real image. So the nature of the image is real, inverted and diminished. Diminished means smaller in size. The position of the object is beyond C here, and position of the image is between F and C. So using the rules to draw ray diagrams, we can find the image of the object formed by the concave mirror. So in the next class we will discuss various cases, that is the object placed at different positions and the image is formed. Now let's move on to convex mirror. For convex mirror, the center of curvature and the focus are on the right side of the mirror. Let us see the rules to draw ray diagrams in case of convex mirror. When light ray is parallel to principal axis is incident on convex mirror, it gets reflected in such a way that it appears to come from focus. So any light ray which is parallel to principal axis, when it is incident on the convex mirror, they appear to come from focus. Any light ray which is parallel to principal axis, when it is incident on a convex mirror, it gets reflected in such a way that it appears to come from focus. So any light rays which are parallel to principal axis, incident on the convex mirror, they appear to come from focus. The second rule, the light ray is incident on the convex mirror in such a way that it is directed towards center of curvature, it retraces its path after reflection. So using these two rules, we can draw the image formed by the convex mirror. Now let us draw the image formed by the convex mirror. Consider an object which is in front of the convex mirror. Draw a light ray which is directed towards center of curvature. It retraces its path. Let us draw another light ray which is parallel to principal axis. This appears to come from focus. Where these light rays appear to meet, there the image is formed. Because the rays do not actually meet, they only appear to meet, so a virtual image is formed. This is not a real image. We cannot capture it on the screen. And the image is smaller in size, and it is virtual, and it is erect. So wherever may be the object in front of the convex mirror, the image is always formed between focus and pole. Nature of the image is virtual, erect and highly diminished. So children, let us revise the other topics in the next class. Thank you.